Today we're going to be solving complementary angle equations. Now the word complementary, if you can remember, means that two angles add up to give you 90 degrees. So in other words, A plus B must be equal to 90. Keep that in mind as we're solving these equations. Okay, and this is just a recall of the definition. Complementary means both angles add up to 90 degrees. Simple. Okay, so here's a diagram that gives us an idea of what two complementary angles look like. Okay, we have angle A and angle B, and notice that we can swivel this a little bit back and forth and see that no matter how we swivel it, A plus B must be equal to 90 based on this little symbol right here, right? So even if it was down here, B would be 10 and A would be 80, 45, 45, 60, 30, and so on. So again, complementary means A plus B must be equal to 90 degrees. Let's go ahead and solve one together. We have A is equal to 2x minus 40. B is equal to 5x minus 80 degrees. Again, notice that if we take A and we add B, we must be equal to 90. That's going to give us a hint as far as where to start the problem. The question says, what is the measure of angle A? So we're going to have to do a few things. Not only are we going to have to solve for this variable x, but we're then going to have to plug that back in to figure out A. That's going to help us with one of our further steps. So let's take a look at step 1 together. Since it's a complementary angle equation, step 1 says to add the angles to equal 90 degrees. So we're going to take both A and B, and this goes for any complementary angle equation. You're going to pick both angles, in this case A plus B, you're going to add them to equal 90 degrees. Okay, so A plus B equals 90, that's step 1. Let's go ahead and take a look at step 2 now. Now that you have that, step 2 we're going to solve for the variable, in this case x. To do that, we notice that A from the original problem was 2x minus 40. Let's take a look one more time. Okay, so there's the 2x minus 40 up here for A, and B is equal to 5x minus 80. So we're going to take those expressions and substitute them in for A and B. Here's A, 2x minus 40. Here's B, 5x minus 80. So again, this is part of step 2, which is solve for the variable. Now that we have that, I'm going to group my x terms together, 2x and 5x. Then I'm going to group my numbers together, minus 40 minus 80. Then I'm going to combine them. 2x plus 5x is 7x. Minus 40 minus 80 is minus 120. Then to get the minus 120 to the other side, we're going to add it. So we have 7x minus 120 equals 90. I'm going to add 120, add 120. That gives you 210. Then we're going to divide both sides by 7. 7x over 7, 210 over 7. X equals 30. Now notice this doesn't solve the problem. That's only the end of step 2. Step 3 is now to take that x value and plug it back into the angle expression. Okay, and maybe this step should say plug variable back into angle expression. Let's fix that. We'll call it value. Okay, it's the variable value. So we're going to plug the variable value back into the angle expression. So we're going to take 30, and since A is equal to 2x minus 40 according to the original problem, we're going to take that x value and plug it back in into the angle expression. So A equals 2x minus 4. We figured out x is equal to 30. Plug 30 back in. 2 times 30 is 60, and 60 minus 40 equals 20. And if we wanted to figure out B, even though the problem didn't ask, we could do B. We know that A plus B equals 90, so B must be 90 minus 20, which would be 70, which makes sense. And if we take a look at the diagram one more time, we can kind of see that well, in this case, it doesn't really look that way, but so we can see that if we take the 20, which was A, and add if we do 90 minus 20, we could see that B is 70. Now I look at it, I realize this doesn't look exactly like 20 and 70. It would be more like this. I guess that goes to show that not all diagrams are perfect. But anyway, we did solve for A, which was 20, which we could write up here, and B, which is 70, in case the question did ask that. That's it.